fur is going to be left positively charged because there is a deficit of electrons, and the ebonite rod is going to be left negatively charged because they gained electrons. So there's an excess of electrons in the ebonite charge. Now, it's a known fact that ebonite becomes negatively charged. So this just happens to work out. Now, as I mentioned before, there has to be work that's done in order to make this change happen, because both of these objects are insulators. They're not conductors. So what happens when we look at conductors? Well, there's another property which I kind of mentioned before, which is conduction, and that's what's going to be happening when we look at conductors. So let's say, for example, when a negatively charged rod, let's say it's this again, is touched to a neutral conducting object, so a metal sphere, for example, some of the excess electrons are going to move over to that sphere. So like it shows in the diagram, what's going to happen is when it's touched, there's going to be a movement of electrons. So why does that happen? Well, it happens because when a positively charged rod is touched to a neutral object, it's going to try and stabilize it, quote unquote. It's going to try and neutralize both objects so that they have the same charge, and that's because of its property as a conductor. Because in conductors, electrons are free to move. In insulators, not so much. They're actually going to be stuck in their own positions within their nuclei and around their nuclei. So when we're looking at conductors, they actually are more in a sea of electrons. So the electrons could be anywhere in these areas, and they're allowed to move wherever they want. So if you bring a positively charged object here, most of these electrons are actually going to cluster and move towards this positive charge. They're going to move somewhere around this area because they're free to do so. They're allowed to move closer to these things, and this is because of that property that we kind of touched on before, where unlike charges are going to attract each other. So conduction is through contact. Another way to think about conduction is contact. So when you're touching two objects together, you're going to have some transfer. So charging by conduction results in the object receiving the same charge. So if I was touching two objects together, one being this ball and the second one being this ball, and I touch them, if one is positive and one is neutral, they're both going to be a little bit positive on both sides, and that's because they're going to be contacted, and every electron is going to try and move to a spot with the least amount of electrons. And so you're going to be seeing kind of like diffusion happening, but it's not diffusion.